Hello and welcome to this video. Today we will talk about data caching. We will talk about application server cache, content distribution network, cache invalidation, and lastly, cache eviction policies. First, let's take a look at the definition and create an analogy to really understand what caching is. Caching is defined as a temporary store of duplicate, frequently accessed data that's kept in a special location so it may be accessed quickly, which reduces latency. There are many types of cache, including CPU, disk, and other hardware, web browsers, web application, and the list just goes on. Caching is basically a technique of storing frequently used data or information in memory so that when the data is needed once again, it could be directly retrieved from the memory instead of being generated once more by the application. It is all about latency optimization. Caching is extremely important for performance boosting. A cache is sort of like a short-term memory. There's a limited amount of space, but is usually incredibly faster than trying to access the original source of data by whatever method you use. Caches are usually located in the front of the system's architecture, where they are used to return data quickly without being far down the stream. Imagine you are researching a paper at a library. To complete your assignment, you need multiple pieces of information from books located on different shelves. So this is a good analogy, I think, for data caching. So without caching, every time you need to look something up, you get up from your desk and you walk to the shelf with the book that you want. You read what you need in the book, and then you walk back to your desk, leaving the book where it is. Because you take so many trips back and forth to the same shelves and books, it takes you several hours to finish your assignment. With caching, when you walk over to the shelf to look something up, you bring a copy of the book back to the shelf next to your desk and you leave it there for quicker access. Now, you don't waste time going back and forth, and if you need to use the same book again, you can quickly find that information right there. So now you have a lower latency. So you finish whatever it is that you're doing much faster. To bring this example into the real world, substitute the shelves with the web servers, the books with the data, and the library with the internet. And this is what caching is all about. Placing a cache directly on a request layer node allows local storage of the requested data. Every time a request is made to the service, the node can then quickly return local cache data if it exists. If it is not in the cache, the requesting node will query the data from the disk. The cache on one request layer node could also be located both in memory, which is very fast, and then on the node's local disk, which is faster than just going to the network storage. If you have a lot of nodes, the request layer is expanded to multiple nodes. In this case, it is still possible to have each node host its own cache. If your load balancer randomly distributes requests across the nodes, the same request will go to different nodes, increasing those cache misses. There's two choices for overcoming this issue, and these are global caches and distributed caches. Content distribution network, or CDNs, are a type of cache that is utilized for sites serving large amounts of static media. In a typical CDN setup, a request will first ask the CDN for a piece of static media. The CDN will serve the content if it is locally available. Then if it's not available, the CDN will query the backend servers for the file, then cache it locally, and finally serve it to the requesting user. If the system we are building isn't large enough yet to have its own CDN, we can ease a future transition by serving the static media off of a separate subdomain using a lightweight HTTP server, cut over the DNS from your servers to a CDN later. While caching provides a load of benefits, it does require some maintenance here and there for keeping the cache up and running accurately with the source. Maybe it's a database or something. If the data is modified in the database, it should be invalidated. If not, it will cause some wonky behavior of the application. The way to solve this problem is the use of cache invalidation. We'll take a look at these three schemes that are often used. The first scheme that we'll talk about here is write-through cache. With this scheme, data is written into the cache and the corresponding database at the same time. The cache data allows for fast retrieval, and because the same data gets written in permanent storage, we will have complete data consistency between the cache and the storage. Also, this scheme ensures nothing will get lost in case of a crash, power failure, or any other system disruption. Write-through minimizes the risk of data loss since every write operation must be done twice before returning correctly to a client, but it does have its disadvantages. One such disadvantage, as you would probably assume, is that latency is a lot higher because of the two writing operations. Next is write-back cache. With this scheme, data is written to the cache alone, and completion is immediately confirmed to the client. The write to the permanent storage is done after specified intervals or under certain sort of conditions. The result is a low latency and a high throughput for write-intensive applications. The speed comes with the risk, though, of data loss in case of a crash or other adverse events because the only copy of the written data is in the cache. Last, write-around cache. This scheme is similar to write-through cache, except here the data is written directly to permanent storage, bypassing the cache altogether. This reduces the cache being flooded with write operations that will be reread afterwards. It has the disadvantage of a read request for recently written data, though. It will create a cache miss and must be read from slower backend storage and experience higher latency. The last topic we'll talk about is cache eviction policies. These are among 6 of the most common cache eviction policies. Cache eviction refers to the way in which data is extracted. We have the first in, first out. The cache evicts the first block accessed first without any regard to how often or how many times it has been accessed before. So think of a line. The first person on the line is serviced before the people behind him. Next, you have last in, first out. The cache evicts the block accessed most recently first without any regard to how often or how many times it was accessed before. I like to think of a stack of lunch trays. In the stack of lunch trays, people choose from the tray on top. They don't go for the first one resting underneath all of the other trays. Least recently used or most recently used discards the least or most recently used. It's pretty self-explanatory. Then we have least frequently used. This counts how often an item is needed. Those that are used least often are discarded first. Last, we have random replacement. Now, this just randomly selects a candidate item and discards it to make space when necessary. So that's a good refresher on data caching. We talked about application server cache, content distribution network, cache invalidation, and cache eviction.